Hello guys, welcome to applications of derivatives and derivatives as rate measure. So I'll be doing 4 questions, 2 questions in this video and 2 questions in another video. So for this chapter, you'll need some formulas like volume of some shapes and TSE of some shapes. So I'll write for cylinder, the volume is pi r square h and the TSA is 2 pi r plus h. For cone, volume is 1 by 3 pi r square h and TSE is pi r plus L. And for sphere, the volume is 4 by 3 pi r cube. You don't really need the TSA for this exercise. So I'll be starting out with a question, and while I'm reading that question, I'll also be writing down or drawing the information to help us solve the question. So here it says a kite is 24-meter high. So a kite is 24-meter high and there are 25 meters of cord out. So when you fly a kite, a cord is typically out like this. If the kite moves horizontally at the rate of 36 km per hour, so horizontally, and we have given time. So if we let this is x, then dx by dt is equals to, we'll write the given here, dx by dt is equals to 36 km per hour. How fast is the cord out? So we'll have to find the rate of change of this. Let's say this is s, let's say this is y. So we have to find ds by dt. Now we can use the Pythagoras theorem to help us out. We differentiate both sides with respect to time. So 2s ds by dt. Now here, this y, dy is actually 0. Because if the kite simply moves horizontally, then at any given time, the height will remain 24 meter. That means the height doesn't change. That means dy equals to 0. That means this whole thing is equal to 0. So we'll have 2x dx by dt equals to 2s ds by dt. So we can cancel the 2's and we have to find ds by dt. So it is x by s dx by dt. Now, what is x? Well, again from the Pythagoras theorem, we have x equals to root s square minus y square, which is root 25 square minus 24 square, which is 7 meter. So here this is 7 by 25 into 36, which gives us the answer 10.08 kilometer per hour. This is the required answer. Now let's do another question. A 2.5 meter ladder leans against a vertical wall. So we have a vertical wall like this. 2.5 meter ladder leans again like this. So we'll say this is 2.5 meter. If the top slides down at the rate of 12 centimeter per second, let's say this is the y, this is the height like this, then given dy by dt is equals to 12 centimeter per second. But here it has given us that the top slides downwards. That means it is minus because the length actually decreases over time. So we have to find the speed of the lower end when it is 12 meter from the wall. So let's say this is x. We have to find dx by dt. Let's say this is s, and again we have a Pythagoras theorem. So here x square plus y square equals to s square. So 2x dx by dt plus 2y dy by dt is equals to 2s ds by dt. Now here, this ladder, because a ladder is a ladder, that means if it slides down, if it moves off, if you push the ladder, if you don't break the ladder, just move it here and there, the position of the ladder, well, the height and the length of the ladder do not change. So that means the change in the ladder well, this part is just 0. So in fact we have, well, we can 2x dx by dt is equals to 2 minus 2y dy by dt. 2 cancels, and we require dx by dt. So from here, dx by dt is equals to minus y by x dy by dt. So here we have to find the value of y when it is 2 meters from the wall. So with the help of Pythagoras theorem, we have s square minus x square, which is root 2.5 square minus 2 square, which is, well, 1.5 meter. And here, since the question is in centimeter, we have to do it in 150 centimeter. Now, you might say, why in the previous video we didn't change the 36 kilometer per hour? Well, because you can again change it back, meter per hour, back into kilometer per hour at the last video. Sorry, at the last part. So here it is 150 centimeter. So this becomes minus 150 by 200 into minus 12 minus minus. This all becomes 9 centimeter per second. This is the required answer. Thank you.